There is so much data out there, and the problem is getting worse and worse by the day. There's so much data that we don't know where it is, what its purpose is, why it lives, why it can we get rid of it? Is it duplicated around all over the place?
It says, okay, I'm ready. I want to deploy AI. I want to maybe also do a bunch of other things with all the vast amounts of unstructured data that I have in my ecosystem. What would be a step-by-step guide that you would tell that person or that team to develop in terms of skills and procedures to unlock that value?
The first step is actually figuring out what you have, ingesting it, being able to get an inventory of what you have. That's the first step. The second step is trying to narrow down that inventory down into a usable set. The third step is actually figuring out what you want to do with that data. Do you want to feed it into a RAG system? Do you want to feed it into, a graph database? The LLM is intelligent, but it's not intelligent, right? If you give it garbage, it's going to give you garbage. Right. And that's the biggest problem. That's what causes hallucinations. That's what causes, incorrect answers. If you look at ChatGPT, it has that little, tagline on the bottom, don't trust the data. It could be wrong, right? You need to check your results. That's why, because if you feed it crap, then you get garbage out. That's all there is to it.
Hello and welcome everyone to the very first webinar from our Aparavi San Francisco office. My name is Hendrik. I'm the AI Product Manager here at Aparavi, and today I'm joined by Rod, our CTO and co-founder.
Thank you, Hendrik. Glad to be here.
Awesome. Today we're going to talk about the 80% of data that your organization is not using yet. But before we dive into that, Rod, maybe I want to introduce you a little bit to our audience. So why don't you give us a little bit of a short journey through, all the things you've done so far, from backup storage systems all the way into heavy data engineering today?
Thank you. So I've been in the data business, the data storage management business for many, many, many years. Worked for a lot of backup companies, built some backup engine. I'm an engineer, so I actually write code. Been in that industry about 7 years ago. Adrian and I, our co-founder, took a look at the backup world and said, there's got to be something more. We're moving all this data. Can we do something with the data while we're moving it? And that's where Aparavi was really born.
Great. And we'll dive into that a lot more. But today we want to talk about, the 80% of data that is not being used in most enterprises out there. So when we say that, what do we actually mean by that, though?
There is so much data out there, and the problem is getting worse and worse by the day. There's so much data that we don't know where it is, what its purpose is, why it lives, why it can we get rid of it? Is it duplicated around all over the place? And that's where we really try and come in and help discover the data, process the data, get it ready for, your AI solutions, prepare the data. And there are a lot of steps in that, whether it be, just recognition of things like social security numbers and, birth dates and addresses and phone numbers, but also, things like social security information, identifying, tax forms. There's so much, to it that, given a file, what is that file's purpose in life?
And when we're talking about all these data formats, often the name unstructured data kind of hits the fan, right? And could you explain to me what exactly actually classifies unstructured data, and when did that problem really hit your radar?
So unstructured data is defined the way we understand it as, loose files sitting out on, an S3 server, in an S3 bucket, or on an SMB share or a file system somewhere. Various locations of individual loose files. Now, a user may actually have some attempt at organization by folders, to try and organize files, but that doesn't scale very well, right? And when an IT guy looks at the folder structure, it's not immediately obvious to him what those files actually represent. That's the way it was. Now, today, we have a lot of different, modes of storage. It's not only file systems, but it's also, blobs and databases. Databases are really trying to store multiple sets of data in blob format. So now we have documents stored in databases. Then you have a whole nother genre of vector databases and, graph databases and all this kind of stuff. So when we define unstructured data, it's not the typical file anymore. It's a lot more than that. It grows. And as that footprint of unstructured data grows, it becomes harder and harder to manage, find it, and actually, figure out what to do with it.
I think, yeah, beautifully said. I think that's exactly what we want to dive into a little bit deeper. So let's double click on that. What is the biggest problems that organizations have when, they're trying to retrieve these vast amount of unstructured data?
The biggest problem they have by far is you have 2 billion files. What the heck are they? Right? You cannot feed 2 billion files into a vector database. It will take you years to do, and it will cost you millions of dollars. So actually, when we talk about, utilizing and uncovering data, there are several passes that you have to make on that. The first pass is actually discovering that you have the files and the data in the first place. If you don't do that, you might as well, you can't even get to step, D. Once you have that, you need to try and figure out exactly what you've got. Right. And you can do that with classification or classification system. You can do that with various other methods of, keyword searching, figure out who has rights to what, and various other methodologies to narrow that, problem set down, because you can't boil the ocean. Right. So you just focus, and that's the key aspect of getting and unlocking your data. It's like you can unlock 100% of your data, but if you throw 100% up there, into a vector database, it's not going to work, right? It's the problem is too large. So you have to focus and narrow that problem set down.
Okay, so what would you tell to somebody in an organization who says, okay, I'm ready, I want to deploy AI, I want to maybe also do a bunch of other things with all the vast amounts of unstructured data that I have in my ecosystem? What would be a step-by-step guide that you would tell that person or that team to develop in terms of skills and procedures to unlock that value?
The first step is actually, figuring out what you have, ingesting it, being able to get an inventory of what you have. That's the first step. The second step is trying to narrow down that inventory down into a usable set. The third step is actually figuring out what you want to do with that data. Do you want to feed it into a RAG system? Do you want to feed it into, a graph database? How do you want to actually use that data? Is it going to be used for, inference on an LLM chatbot? Is it going to be used to, pull out specifications out of a drawing for, engineering work? What do you actually want to do with that? And those are two really different problem sets. The first one is actually, finding, discovering, and preparing. The next one is utilizing what you've done in the first step.
So I'm hearing two things here. One of them is the entire organization and discovery part, and then the other part that has more to do with action on that data.
Yes. Discovery and then action, because then once you discover, then you can narrow your problem set down to the actions on only the data that you need to take action on.
So let's click for 1 second on the discovery piece, because I think there's already a lot of value right there. Can you maybe tell us of like a customer example where you found that people were able to, through only the discovery process alone, mitigate risk or get a lot of value?
So the discovery piece is actually just going out and creating a catalog, creating an inventory of what you have, and with that inventory, you get several different aspects with the Aparavi system. The first one is things like sizes, PDF files, docx files, but we go one level deeper in that. We actually catalog the words in it, so you can do searches and things like that to find documents. The other thing we do is actually deal with permission sets. So I'll give you an example. One of our customers, about a year ago, we scanned their whole system, and we discovered that they had a public share of all the payroll data. Okay, now imagine how big of a problem that would be, if you didn't discover that. With Aparavi's tools, you can go out and look for excessive rights. You can go out and see who has particular rights to a particular folder or a file, effective rights and things like that. But that's all available because you can do the inventory. You know what you have, and a public share is not necessarily a bad thing if it's a public file set, right? But once you see that you have, that public set, then you need to go in one level deeper and say, okay, what have I granted access to? Payroll data? Oops, big problem. Right. So there are a lot of things in that inventory that is very valuable. It really is pulling out data. Let's face it, it's what the operating system should be doing in the first place. Unifying all this data, whether it comes from Gmail, whether it comes from an S3 bucket, Azure Blob, SMB share, you need one single view of all these things so you can manage it. Another thing that's very valuable about that is you can tell duplicates. You can actually determine which is the master file, which was the original file, and which are copies. And you can remove all the copies. One of our customers had 2,000 copies of the same file across, I guess it was a chili recipe from, last year's chili cook-off or something. I don't know. But it was 2,000 copies of the same file. We could determine exactly which was the master file so they could go out and remove all the other files and save us a significant amount of money on not, I don't want to say deduplication, but I guess it is deduplication.
Data reduction.
Yeah, data reduction. There you go.
Right.
And that can be done across, different file systems. You can tell that, okay, somebody uploaded this chili cook-off recipe up to S3 and put it, or OneDrive and put it in their personal bucket, but I've got it on this share, so I don't need the one in OneDrive. So, I mean, that's the kind of information that an IT person preparing the data for AI really needs to know. Then there's the migration use case, where you can actually take the data that you're in an inventory and say, okay, I want to move this up to S3, or I want to take this Azure bucket and migrate it to S3, or S3, I want to put it on my SMB share. So it allows you to manage and move the data based on criteria that you specify, not just massive copies of everything.
Right. And beautifully said. I think there is this regulatory pressure, or the risk of potentially expertizing something like PII in a file share that we just talked about, right? But now I feel like executives around the world are pushed for data discovery for another reason, which is this entire AI adoption curve, right?
Yes, we started out, 7 years ago about, data management and understanding the content of data and, really being able to leverage and figure out your data landscape. Then AI came along. Okay. And we said, oh, we've got the tools. We have the data. AI without data is just AI, right? It's two letters, AI. Without the data, it's useless. Okay. So we had all this data landscape. We knew everything about the system. So how can we leverage that to feed into the AI systems and actually unlock that data and utilize it for business purposes and get real business value out of what we've already ingested? That's when we kind of, I guess, merged, or the product with AI, because it's a perfect use case, because without data, AI is useless.
So how can I, if I deploy the strategies that you just explained, bring my AI project from zero to hero?
So the thing is ingesting the data, figuring out what you need to do with the data, ingesting it into your AI systems. Now that can be done in a simple RAG system. A simple RAG is parse the data, pull the text out, and we support 1,600 different file formats. So take the text out of it, put it into a preprocessor to chunk it up. Then you do embedding on it to get the embeddings, and then you throw it in a vector database. That's naive RAG. Okay. But pipelines can be built, which are much, much more sophisticated, where you can do summaries, you can pull information out of tables, do object recognition, pull things out that normally would not be available, to your standard, text-based, workflow. So that's what you really need to do. And then along the way, there's another filter in there called anonymize, which can actually look at the data you're putting into your vector database to make sure it doesn't have social security numbers and birth dates and addresses and phone numbers and EIN numbers and all that kind of stuff. So when you actually go put it in your vector database, you're pretty secure that it's clean data.
The fundamental key to AI success is really about enabling your organization to feed in the enterprise data you have securely into your large language model.
Securely and the right data.
Right. Can you give an example where sometimes we've maybe seen a customer in the out where they haven't done these steps and it, went bad?
So I'll give you an example of my own personal experience, okay? I have my tax returns on my, my PDF tax returns on my system, my laptop, and I have them for the last 20 years, okay? I've been using TurboTax a long time. So I got the PDFs, and I mean, they're lengthy, long PDFs. And from my own personal experience, when I first started with the AI project, and seeing how we could interface with AI, I naively just took those documents, pulled the text out, and stuck it into a vector database and all that kind of stuff. Okay, it worked perfectly. Okay, I could ingest the documents, but then you start asking questions on those documents, like what was Rod's adjusted gross income. But if you look at the document says, 2004, 2005 at the top, but the adjusted gross income is way down here, on page 32. But nowhere on page 32 does it say 2004. Okay, so now you've got a context problem because the context is so far away from the document you wanted. So now what I was getting is every chunk that said adjusted gross income fed into my LLM, right? And I had 30 chunks, from all these different years and all these different, areas within the documents that it said. It couldn't answer the question. It just, it failed because it had conflicting information. So that's the naive RAG system. So a much better approach is to summarize the document first, say this is 2004, and then take that summary and the documents that we put in that summary, and then filter, the chunks that we receive only to that document set. So therefore, it could actually pick up, the correct adjusted gross income for that year. Does that make sense?
That makes total sense. So just to summarize for myself here, it's really AI, even though it feels often like it does not quite come for free. Good AI needs the proper data at the right time. And that's really what makes an essential AI pipeline and AI project successful at the end of the day.
The LLM is intelligent, but it's not intelligent, right? If you give it garbage, it's going to give you garbage. Right. And that's the biggest problem. That's what causes hallucinations. That's what causes, incorrect answers. If you look at ChatGPT, it has that little, tagline on the bottom, don't trust the data. It could be wrong, right? You need to check your results. That's why, because if you feed it crap, then you get garbage out. That's all there is to it.
I have one more thing that I wanted to touch upon and get your opinion. Many people are now talking about LLM fine-tuning and, small language models. How do you think a tool like Aparavi or any other tool could be used out there to feed enterprise intelligence into these fine-tuned models? And what do you think enterprise data will play a critical role in these types of applications?
That's a very interesting question because I think it is subjective. Okay, in my opinion, it's subjective. I've talked to Microsoft AI engineers, and actually fine-tuning an LLM is an exercise in futility, okay, because they're so smart these days, right? Actually trying to get them on your enterprise data is really, you'd have to feed in your whole data set into the fine-tuning algorithm in order to gain any benefit. And Microsoft's actually, I believe, done studies that says an untuned LLM is just as good as a tuned LLM. That said, there are models that can be fine-tuned, like your embedding. Your embedders can actually be fine-tuned on, industry-specific knowledge that actually gives you better vector results and vector queries than, a standard, embedding algorithm. So depending on what your use case is and where you're trying to fine-tune, some can benefit from it, others really don't benefit very much at all.
And how would you say that circling back around here into that discovery piece, a fine-tuned embedding model on company data could become very, very beneficial?
So there's another use case that we have that we're working on, which is really a pretty cool use case. I'm very happy about this. So, one thing that LLMs are very good at is natural language text to SQL statements. Okay. This is a perfect use case because people want to interact not only with their structured, unstructured data, but their structured data as well. So how do you do that? How is that actually accomplished? Well, the first thing is you feed it the question, you tell the LLM to go out and, convert it to SQL. Well, okay, you get some standard SQL, and it looks okay, but it's completely making up the tables because it has no idea. So the first step you actually have to do is go out and get your entire database schema and then pass that over to the LLM so it can figure out exactly what tables need to be joined, what the primary keys are, what the data columns look like, so it can target it, right? And so it can target the SQL statement to that particular database. But that still introduces a problem because companies have their own lingo, right? The companies have, acronyms and, different ways of saying things. And then the LLM doesn't necessarily understand that, right? It doesn't necessarily get the fact that you're calling a marketing document an MRD. So the interesting use case that we came up with, the solution we came up with is we take company documents, standard documents, whether they be, marketing documents or emails or chats between two people. We ingest those and create what we call the dictionary. And the dictionary is designed to say this phrase and explain it to the LLM. This phrase and then explain it to the LLM. So before we actually take and generate the SQL statement, we run the user's question through that dictionary to get all the applicable business specific, terms and items so that when we do pass those over to the LLM, when somebody's asking for an MRD, the LLM actually knows what an MRD is and can actually, here's the description of it so it can make much more intelligent decisions on what SQL it actually generates.
I think that's a beautiful use case and actually leads me right over to something that I'm also very, very interested about, is that intersection of structured, semi-structured, and unstructured data in an advanced retrieval augmented generation system. How do you see those different formats interplay with each other?
So, as I mentioned earlier, the lines between structured and unstructured are blurring very quickly. Okay. And the LLM doesn't care at the end of the day whether it came from some structured database or whether the information came from a document, right? It doesn't matter to it. It's just context. So when we look at how these pieces fit together, the pipelines need to be able to go out and do database queries. They need to be able to add tables or add, rows. Another example that we worked on, this is a really cool example. I love this example. Over in Europe, they have something called ESG, just like over here, right? So one of the targets that, apartment complexes, this was an apartment complex, actually had to do is track usage, power usage, kilowatt hours for every apartment, and then give a chart for the usage for each different apartment and show the whole building was being more energy efficient. That was a completely manual process. They had to actually go out and get the bills from, duplicate bills from all the, for all the different apartments and sit there and have somebody type in the hours. With automation and an LLM, that is so simple because we can take and extract the tables, extract the information from the document, right? And then we can actually send those over and say, added to this particular table, here's what I'm looking for: the kilowatt hours, the apartment number, the address, the whatever information you want to extract from that document. We can extract it as a SQL table or a table, and then take that table and add the rows into a database. So it's both ways, really. It's actually doing the query on the database, but also injecting into the database, from information pulled out by automation.
Beautiful. I think we wrapped the whole whole word into a conversation here. Before we open it up to question, I'd love to give you an outlook. Where do you think the journey of unstructured data, especially enterprise unstructured data and AI, is leading in the coming years?
So I think from my perspective, I'm very interested in multimodal. Right, it's one of my real hot topics: video, audio, image, and text. Okay, as a matter of fact, we have those for what we call lanes in our product so that we can do various things with it. I think there's so much rich data in, videos, within images, recognizing an image, the purpose of an image, the specifications of an image. We got this one image from a customer that had a person, and it was an engineering image on, how big a seat had to be, how tall it is, where the person is actually going to fit. Up until now, that would have to manually be entered into a system and interpreted by a human. But now you can take that AI, pull that information out, and either do a summary on it, stick it in a database table, whatever you need to do with it to process it further. But that's an example of where the multimodal really comes, into play, is because there's so much rich information in everything besides just text. So over the coming years, you're going to see AI companies leverage a lot more of that multimodal data.
Awesome. I think with that, we'll close it for this conversation here, and we'll give our audience the opportunity to, maybe shoot one or two questions. Yeah, please, we'll be kicking off that webinar series in the coming months to come with different guests coming over. So we'll be excited to hear your feedback. For any starring guests that you would like to see or any topics that you would like to have covered. We do have an announcement to make as well. In the next 48 hours, we'll be launching our cloud-hosted Aparavi data toolchain for AI, a tool that we covered extensively in this conversation, partly at least. And we'll be excited for you to test this out. Every participant in this webinar here will receive a promo code on their email to join the first preliminary round of developers that we give access to this tool. Watch out for that, and we'll be excited to hear your feedback.
Thank you, Hendrik.
We'll talk soon.
Appreciate being here.
All right. See you next time.